In this class, now I am going to explain you standard form of pair of straight line passing through origin and also how to determine angle between them. Now let us consider a coordinate system. This is x-axis and this is y-axis. Take two lines which are passes through origin. These are two lines which are passing through origin. This is origin. You know, standard form of a line which passes through origin. Let us consider this line equation as L1x plus M1y which is equal to 0. We don't get constant term. Here also L2x plus M2y which is equal to 0. So these are the two lines which are passing through origin. You know, standard form of a line equation ax plus by plus c equal to 0, but which are passing through origin. Hence here we don't get the constant term. Ax plus by which is equal to 0 you will get, because that is passing through origin. Hence, so that c would become 0. Constant part never come in this. Now take the product of these two, because we are going to write the combined equation of these two. See, L1x plus M1y into L2x plus M2y which is equal to 0. So now, so this is one line equation and this is one more line equation. So what we are going to get by taking the product of these two, whose combined equation, that is known as equation of pair of straight line. Pair means you know, which constitutes two line equations. So take whose product, see L1 into L2, x square you will get. Now multiply this with this so that you will get L1 M2 xy plus take the product of these two, L2 M1 xy plus product of these two, M1 M2 y square which is equal to 0. So here L1 L2 x square, from the middle to take xy common so that you will get L1 M2 plus L2 M1 xy. So here M1 M2 y square which is equal to 0. In the next step, consider this one as A, this one as B, this one as C. So if you treat this one as A, this one as B, this one as C, then it would become ax square plus, so this middle one. So take this one as 2h, take this one as B. Then it will become ax square plus 2hxy plus by square which is equal to 0. So this is the standard form of pair of straight lines passing through the origin. I hope you have understood. So what does it represent? Pair of straight lines passing through the origin. And it is a homogeneous equation. So observe here, A and this 2h and this B are constants which belongs to the real numbers. But see here, x and y are variables, locus point. So what is the power of x? 2. Here power of y? 2. So here power of x and y? 1, 1. If you add them, 1 plus 1, 2. Here power of x is 2, power of y is 2, power of xy. So to get the degree, you would have to add power of x and y. So here we are getting the degree of the middle term 2 and the degree of the first term 2, degree of the last term 2. Hence here we found that degree of all the terms are equal. Hence it is a homogeneous equation. Homogeneous equation. Sometimes they will give you this homogeneous equation and you have to resolve into the factors so that you will get these two line equations. So see, for example, here you may get one combined equation like this: x square plus 3xy plus 2y square equal to 0. This represents pair of straight lines passing through origin. Then find those two line equations. In such case, what you have to do? Just you have to resolve into the factors. So x square plus, so if you factorize, so what do you get? Split the middle term. 2xy plus xy plus 2y square, which is equal to 0. From the first two terms you can take x common, so that here you will get x plus 2y, and here from these two you can take y common. So x plus 2y, which is equal to 0, you will get. Here x plus 2y, x plus 2y, again take common. So here x plus y, which is equal to 0, you will get. Now equate both of them equal to 0. On equating this one equal to 0, you will get x plus 2y equal to 0. This is one line equation. On equating this second factor is equal to 0. So x plus y is equal to 0. This is equation 2. So both are linear equations in two variables whose graph represents a straight line. So here in both of them there is no constant term, hence which are passes through origin. Like this you have to get the lines which involves in this given equation. Sometimes this factorization is so difficult. In such case you can use this formula. See here, ax square plus 2hxy plus by square is equal to 0. This is the equation of pair of straight lines which are passes through origin. Then find those two line equations. In such case you can use this formula: ax plus h plus root of h square minus ab into y, which is equal to 0. Next, ax plus h minus root of h square minus ab into y, which is equal to 0. So these are the two line equations which are involved in this pair of straight lines. Okay, if the factorization is possible, then follow that factorization procedure and evaluate whose line equations. If the factorization is so difficult, in such case you can use this formula. So collect this a, b, h value from here and substitute in this. Here a, here h, here ab. Substitute here and simplify. And here you have to remember three conditions. See, okay, they will ask you, this pair will be given to you, and whether it contains two distinct lines or coincident lines or imaginary lines. So this kind of questions will be given. In such case, see, you have to check this condition. Whenever the h square is greater than ab, then this pair will contain two different real lines. If h square is greater than ab, then given pair contains two distinct given pair contains two distinct real lines. Two distinct real lines which are passes through origin. Remember this point. So sometimes, so you will find h square is equal to AB. H square is equal to AB. In this case, you can say that both are real lines, but both will be coincident. Both will be coincident lines. And if you find h square is less than AB, then in such case you can say that both are imaginary lines. Okay, students, remember this point. And one more question can be expected from here. Find the angle between the two lines which are represented by this pair of straight lines passing through the origin. So in such case you would have to use this formula. Let us consider angle between them is theta. Okay, so cos theta is equal to mod of a plus b by root of a minus b whole square plus 4h square. Use this formula so that you will get angle between them. You know, whenever the lines intersects each other, so you get one is acute angle, one more is obtuse angle. So if it is theta, then it will be 180 minus theta. So here I used modulus symbol, means it should be always positive, so that here you will get an acute angle. Okay, so if you know the acute angle, you can able to find obtuse. So in the options, however it may be given, they may give you acute angle or obtuse angle. So sometimes while doing the application, you may get theta as 30 degrees, but in the options they may not give you 30 degrees. So then what they may give you as 150 degrees. So this 30 must be subtracted from 180, so that you will get obtuse angle 150 degrees. You can use this formula. Cos theta is equal to mod of a plus b by root a minus b whole square plus 4h square. Next, sin theta. Sin theta 2 into root of h square minus ab by root of a minus b whole square plus 4h square. So suppose if you want a tan theta, then you would have to divide sin by cos. You know, tan theta can be written as sin by cos. If you divide this by that, so that you will get 2 into root of h square minus ab by mod of a plus b. Okay, students. So suppose if theta is 90 degrees, if the angle between the pair of lines which are represented by this is 90 degrees, so in such case what do? Put this theta is equal to 90 degrees. If you put here theta 90, cos 90 which becomes 0. So if it is 0, then bring it to the left side. 0 into something which becomes 0, so that you will get a plus b equal to 0. If theta is 90, then a plus b equal to 0. What is a? In the standard form, coefficient of x square. What is b in the standard form? Coefficient of y square, whose sum should be equal to 0. Coefficient of x square plus coefficient of y square equal to 0 whenever the angle between the pair of lines represented by this is 90 degrees. Okay, students? Thank you.